We're going to be looking at proportional reasoning, and the method we'll use to solve this question is a table of values. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to illustrate equivalent ratios using a variety of tools in this example table of values. So our inquiry question. Let's read through it once and then highlight what we think is important. On a sunny day, a flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. At the same time, a tree beside the flagpole casts a shadow that is 4 meters long. How tall is this tree? Okay, so let's highlight flagpole stuff with yellow. On a sunny day, a flagpole is 6 meters tall. I assume it's that on a non-sunny day too. But its shadow is 2.4 meters long. So that's also very important to us. At the same time, a tree beside a flagpole casts a shadow that is 4 meters long. Okay, so the tree has a shadow that's 4 meters long. How tall is this tree? Okay, and I highlighted the tree in green just to help us organize. So because it's describing a relationship, I'm going to try to have a visual with it. I find visuals very helpful, especially with word problems. Our black line represents the flagpole and our gray line the shadow. The height of the flagpole was 6 meters, and the shadow it happened to cast was 2.4 meters. Okay, so here's our flagpole. We'll also draw this type of relationship representing tree. The tree will be a little taller because if you notice the shadow length is longer, which would probably mean that the object itself is a bit taller, the tree over the flagpole. So here's our tree. The height of the tree was our unknown. We have a question mark. We usually in math use the symbol of X to represent an unknown. And the shadow was 4 meters in length. Okay. Now we said we want to use a table of values. So for a table of values, we have to look at which of the objects we have most, if not all, our information about. And that happens to be the flagpole. Okay. So flagpoles are going to be our starting point for our table of values. And we have to categorize everything. With our table of values here, okay, we have our height of an object. Okay. So height. And our shadow. Okay, and the height referring to how tall something is, the shadow referring to how long a shadow is. Okay, now if you recall, I'm going to put the flagpole as a second, so I'm just going to use F to represent it. The height of the flagpole was 6 meters and the shadow was 2.4. Okay, now I want you to think of this type of relationship. If there was no height, would there be any shadow? No, if we don't have anything there, it doesn't cast a shadow. So this is also a coordinate along our stuff. This is a directly proportional relationship. So make some room here. Let's drag this down a little, just for our purposes here. Now we kind of want to figure out what this is increasing by, and we can really have our values increasing. It is a direct variation. So whatever we do to one side, the height, we're going to be doing something increasing by a constant value the shadow side. This is a linear type of relationship. All that, a lot of words to it, but let's try to figure out what we're doing. We want to go from 0 to 6, okay, and maybe we want to break this down into steps, which we usually do in a table of values. If we take a look here, essentially we've increased by the value of 6. Okay, and when we increase height by 6, we increase shadow length by 2.4 meters. Okay, so that's great. Okay, and let's continue. I'll put our tree information in here also. Okay, maybe let's go a little longer here. Good. Let's get our tree info. Remember, our tree info was about 4 meters. Let's put it here, and our height of our tree was unknown. The only problem, and I think it'll be easier if I do zoom in, if I increase by, say I increase by 6, let's say we increase this side by another 2.4. Well, 2.4 plus 2.4 is going to be 4.8. That's going to give us 12. We've kind of skipped our tree. So we need something, an increasing value that will be better. Because all of our info is on this side, we want to figure out how much to increase by on this side every time to figure out our tree height. Okay. So a value that might be nice to look at here, especially because we have 6, what we can do is we'll take our shadow and we'll divide by our height. Okay, so we'll take our shadow was 2.4, and we'll divide by the height. Okay, and this will give us a ratio for what we're increasing by every single time. Okay, and what it will do is we'll figure out when we divide these values, we'll get, take out our calculator here, 2.4 divided by 6 equals 0.4. So what we've just figured out there is we get 0.4. Okay, and great, we increase shadows by 0.4, but what's our height increasing by in these cases? Well, when you divide by a value, think of it like creating an equivalent fraction where the bottom on the the number on the bottom or the denominator is now a value of 1. So what we've just figured out, okay, is that every time we increase by 0.4 here, our height increases by a value of 1. That's pretty helpful for us, okay? So if we were to increase another 0.4, okay, we go up another 0.4, we get 0.8, and our height would be 2. So using the information we have, let's kind of move a lot of this down again. Let's see if we end up with our 6 and 2.4 and make sure that's correct. Okay. That means we're going to go 3, 4, 5, and then 6 would be there. So let's move 6 right into it, and 2.4. Okay. So every time we increase by 1, we should be increasing by 0.4. You can use a calculator to go along. I'm going to do this in my head. We increase by another 0.4, we should get 1.2. Another 0.4 gives us 1.6. Another 0.4 gives us 2.0, and another 0.4 gives us 2.4. Perfect. It checked out. So we're at the number 6 now. So now we've got to get to 4 on this side. So let's increase by another 0.4. Okay, that'll give us the 2.8. Let's increase by another 0.4, and that'll take us to 3.2. It's not quite there, so let's move our info down a little. Let's get these to connect. There we go. Okay, let's increase by another 0.4. We get 3.6. And then when we increase by another 0.4, we get to the value of 4. Great. Okay, and this is where we want to be in height. So we've now increased that 1, 2, 3, 4 more times. So we need to increase this 4 more times. So we go up 1, that would take us to 7. Another one, 8. Another one, 9. And then finally, another one gives us what number should come in here in our pattern, but 10 meters. So according to our table of values, the tree is 10 meters tall. Okay, in other words, x was equal to 10 using this table of values. If you would like to see other methods to solve this, you can check out our other playlists on proportional